Let us now explore how to represent real life situation in mathematics. We take help of algebra. Okay. Now here are a few examples which will give you an idea about how the two things can be related. We say speed limit increased by 5 kilometers an hour. So let us say if earlier speed limit was something like s, now it is increased by 5 kilometers. That means you add 5 to that, right? So it becomes kind of an expression, and since it has a variable, s could be any speed limit. So let us say we have a zone where speed limit is, let us say, 60 kilometers an hour, and now it has been increased by 5 kilometers. So now the new speed limit is 65 kilometers per hour. Okay, so this expression s plus 5 represents that increase, right? Now s could be any speed limit. If there is another zone where the speed limit is, let's say, 40, so in that place it will be 40 plus 5. So it gives us a flexibility to work with the situation, right? Now, second is gas prices dropped by 10 cents. Well, that's kind of a celebrated event, but how can we write it in algebra? So in algebra we can say let the gas prices be G and then it's minus 10 cents. So it's lower for a change. So that's a nice thing, right? So we use operator negative, minus, or subtraction to represent decrease in or drop in prices. Now let's have temperature dips 5 degrees centigrade lower. So in Canada it happens so many times. It may even dip by 10 degrees in just few hours. So we can write this as let the temperature be capital T, and dips means comes down, and lower is still qualifying it, minus 5. So it gives flexibility. So we really don't know what the temperature was. Let us say if the temperature was 10 degrees centigrade in plus, and if it dips by minus 5, that means goes down by 5, then the temperature becomes 5 degrees, right? So it's a general way of representing a situation. But in any case, we have represented a real life situation in the form of mathematical things, right? A variable, operator, and a constant number. Now here we have doubling of investment, right? We all are trying to do so. So let us say doubling means twice, right? So twice the amount A. So if initial investment is, let us say, A, then doubling will be 2 times A, right? So here we are not writing anything. We could have written this as 2 times A, right? But 2A is same as 2 times A. We prefer to write 2A. But in any case, another real life situation has been now written as an algebraic expression, correct? Mathematical in nature, which we can manipulate and work with. Then we have product of length and width. We use so many times. What is area of a rectangle is product of length and width. So we have two variables in this case, length and width. So we multiply the two to get area, right? But we are still working on expressions and we are avoiding equal to sign. As you'll note, in all these expressions, we have one thing in common, that is variable, operator, and number, correct? Now, sharing among friends is always good to share, and sharing among 4 friends means you get quarter of whatever you have. So let us say you have something, let's say you have X amount, and when you share with 4 friends, it gets divided by 4, which we could also write as X over 4, correct? Now in all these situations, what you see is few things. That is, we have something here which we call variable. Variable, since now these values can take any amount or any value. Sharing among friends. You could have $10 which is being shared amongst friends. You could have pizza sharing among friends, right? But it's a very general way of writing. See the flexibility you get by representing the situation in algebra. It can be applied in so many different ways, right? So that is one thing which we see. And here right in the middle, we have seen some operators. We call them operators. Now operators which we are going to use are as listed here, plus for addition, then minus for subtraction, multiplication, and division. These are the common operators which we will be using now in our playlist to explain how to translate real life situation into algebraic expressions, and then later we'll graduate to algebraic equations, okay? And then we have these numbers here, right? So we call these numbers as constants, which you can say numbers, okay? So there are numbers. So what you see in common here is that we have a variable which can take any value, and then we have constants, and in between we have operators. So when these things work together, it makes a lot of sense, and they can translate any given phrase which we have seen here, or a sentence, or a real life situation into algebraic expression, right? So what we did all along in this is, these were our phrases, right? Or sometimes we could say even words or sentences. And what we did here, we wrote something like this, which we called algebraic expression. Now here you'll note one thing, that you do not see what? You do not see equal to sign. That equal to sign, right? So if we put equal to, it becomes algebraic equation. At present we are not talking about calculating anything, we are not talking about finding any particular value or solving an equation, right? So in all these cases, remember one thing, that we will not be using, so do not use, do not apply equal to sign, okay? So that is kind of a precaution which you have to take in all these cases when we discuss. From now onwards, when we are talking about algebraic expressions, right? So we'll talk about algebraic expressions, and in algebraic expressions, as you see, we will have a variable, an operator, and a constant, right? There could be more than one variable, there could be more than one operator, there could be more than one constants or numbers, but there cannot be any equal to sign. And the beauty of algebraic expression is that it kind of gives you a general way of representing real life situation, correct? So that is what it is, and we'll discuss more in details in the following videos. But I hope you get the concept here. So it is important, when you have a phrase, first define your variable. Speed limit increased by 5 kilometers an hour. So let the speed be s, then the speed limit increased by 5 kilometers an hour can be written as s plus 5. Gas prices dropped by 10 cents. Let the gas prices be G, then G minus 10 represents gas prices dropped by 10 cents. Temperature dips 5 degrees centigrade lower. Let the temperature be capital T, then T minus 5 is same as temperature dips 5 degrees centigrade lower. Doubling of investment. Let the investment be A, then doubling will mean 2A. Product of length and width. Let L be the length and W be the width. Then the product will be L times W, right? We could always write this as L within bracket and W, right? Even you can write like this. Or if you write LW, it will also mean the same thing, okay? So we prefer actually this way of writing when we are talking about product, or this. Sharing among 4 friends is like dividing, right? So if you have an X amount, X divided by 4. Now divide can be written as X over 4, or sometimes we also put it in ratios, right? X is to 4, sometimes. Well, in this situation, these two are better option. In fact, X divided by 4 is probably the best when we are talking about algebraic expression in this particular case. I hope you get the concept. Algebraic expressions will always have a variable and an operator and constants, right? But it will never have equal to sign. And it is a very powerful way of representing a real life situation into mathematical, and we call this, it is in a way mathematical language. So translating real life situation into, I should say, mathematical language. language, right? There's no space here, so I'll just squeeze in language under. So that is kind of a mathematical language for us. And now we'll talk in terms of algebraic expressions, which is mathematical language and which is going to help us solve many real life situations. I wish and I hope you will really appreciate this topic and you'll love it soon. Thank you.